we have to put up with this kind of semi-annoying beeping in the background, but that's the only downside. All right, so what kind of trig are we going to do tonight?
We're doing sinusoid, I believe that's what they're called.
Okay.
Wave graph.
Tell me if this is your standard general function.
Yeah, but instead of C and B, we use H and K, but yeah.
Okay, but the B is outside of the parentheses?
So, I have B inside the parentheses.
Okay. There's actually 3 different formats. Is that yours?
Well, kind of like there's a parenthesis between the X and the B, but there's also parentheses around the B. So it's pretty much the same as the first one.
Okay, because there's a big difference here. The second one is not the same as the first one at all. In the first one, I can say that the phase shift is C. In the second one, the phase shift is H divided by B. So it kind of depends on what they give you. And either one are just as valid as the other. But it, like I said, depends on the sinusoid function they give you. You have to make sure you know whether that B is inside or outside the parentheses, because it will affect the phase shift. It will not affect the period. The period's going to be the same regardless, but it definitely affects the phase shift. So I'll assume this is what we're going to be looking at, and we can tell, if you give me some functions, I can tell which format it's in. So they'll make you do it 2 ways. They'll give you functions and want you to graph it, and they'll give you graphs and want you to come up with the function. Now, the first one we're going to be able to do just fine online, where if you give me the function, we can figure out how to graph it.
Okay.
The second type, the best way to do that is going to be for you to take a picture of the graph with your smartphone camera and send it to my email address. And then I'll be able to pull it up on our screen and we'll be able to look at it and go to work on it. But the one thing that's quite difficult to verbalize are graphs.
Yeah.
So we can do whatever you'd like to do right now. We can work on going from function to graph, and we can do that the whole hour. But if you want to go the other way, if you want to go from graphs to function, you probably need to take a picture and send it to me while we're talking.
Let's just start with function with the graph for now.
Okay. What's the first one?
First one I have is 3 cosine x.
What's A?
3.
What's B?
1.
What's C?
Would it just be 0?
Uh-huh. D?
Also 0?
Uh-huh. So, if we take our traditional cosine curve that starts right there at 1 and ends at 2 pi, and it goes through these quarter points, and its lowest value is -1. So I know this is a regular cosine curve. I know it's got to go through all 4 of those points.
Okay.
Looks like this. What's the only difference between this, which is y equal cosine x, and what we're looking at? What's the effect of the 3?
That'll increase the
It's a vertical stretch factor by a factor of 3. And it does change the shape of the curve. In other words, it goes all the way up to 3 and all the way down to -3. So it looks a little steeper. It still goes through the same quarter points, but it just looks like your normal cosine curve stretched. What do you have next?
I have 0.5 cosine 3x.
A is 0.5. What's B?
That would be 1. Oh, 3.
What is the period? In other words, B always is, the period is 2 pi over B. So what's
so
the...
2 pi over 3.
Uh-huh. C again is 0, D again is 0. So we basically have two things going on here. I'm going to draw the cosine curve, and then I'm going to draw this curve. The consequence of A being 0.5 means what?
That would be do a vertical shrink by 1/2.
Yeah, so it's going to go from 1/2 to -1/2. What's the consequence of the period being 2 pi over 3 instead of 2 pi?
The period will be shorter.
It acts as a horizontal compression.
Okay.
So I've got to complete this entire curve by 2 pi over 3. We'll call that 2 pi over 3. Let me go up here and choose a different color. Now, in other words, I got to go from here. Well, actually, I'm going to start right there, right?
Yeah.
I got to draw the entire cosine curve and finish right there. So I need to break up this interval that now goes from 0 to 2 pi over 3. I need to break that up into quarter points. What's the middle point right here on the x-axis going to be?
Not really sure how to find that.
Divide that by 2. What's 2 pi over 3 divided by 2?
2 pi over 6.
Which is, yeah. Well,
Pi over 3.
yeah, I'm even going to label it as 2 pi over 6 just because it makes for understanding it a little bit better. And I've got to divide this thing into fourths, so I got to split that in half and split that in half. So this quarter point is what?
That'll be pi over 6.
And this 3/4 point is what?
3 pi over 6. So that just be pi over 3.
Yeah, let's leave it in sixths for the moment. Merely because it's a little easier to understand it if I don't simplify it. In other words, this would be 4 pi over 6, right? So the 4 quarter points are 1 pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. And they're important because I'm going to draw the curve now. I know where everything has to go. I know it has to start on my first x. it's got to go through the first quarter point there. It's got to hit its minimum minus 1/2 right there. It's got to come back up through the x-axis at the third quarter point, and it's got to end at the fourth quarter point. So I can draw it, looks like that. Okay?
All right.
What else?
Hold on, let me read this real quick.
I'm sorry, what? I didn't quite hear that.
So this one, it wants me to, it says specify the period and amplitude function, then give the viewing window which the graph is, in which the graph is shown.
Okay.
So they sending pictures.
Okay. Do you need an email address, or do you have it in front of you?
I might have it on my phone.
You know what? You might have David at Digital Math Tutor. A better one to send it to is David Cowan, only because I'll get it quicker. 1949 at gmail.com. Make sure that that's the one you have in your phone.
All right. Okay, so
Yeah, if you hold the camera about 12 inches away from the piece of paper, and you might have to use the flash, especially since it's dark, unless you have a lot of good light in the room you're in.
right.
And just hold it steady. That's the most important thing for taking. Or you have a burst mode on there?
I might, but I gotta get a picture here. So.
Okay.
So you said David Cowan, 1949?
Yes. Just as you see it there. I would get it if you sent it to the other email. It just has to be forwarded, and I've found that that can take like 30 minutes sometimes.
Oh, wow.
So, yeah, whenever we're in a session and you're sending me something, make sure you send it to this email address. It's a pretty big jump we made from last session to this session.
Yeah.
Going from the unit circle to sinusoid functions.
Yeah, I'm in the, kind of like the honors version of trigonometry.
Uh-huh. Okay. Well, we're going to get some good ones then. Because this sinusoid function, they can give you some pretty difficult real-life problems, like tides, problems, breathing, anything that's periodic in nature. There it is. All right. So we want to look at 13 and 14?
Yeah.
Okay, 13, what's going on? We have two things that are happening. What are they?
A vertical stretch and a phase stretch, is that what it's called?
A period compression. In other words, the period, it's important to know the period of an uncompressed one. Okay, if I draw a sine curve and I draw one cycle only, that goes to 2 pi. In other words, the natural period of your sine function is 2 pi. So the effect of this 2 makes the period what?
That'll half it, so it'll go to pi.
Yes. Remember that the period is equal to 2 pi over b. So if b is 1, you have the natural period. If b in this case is 2, then this whole thing would have to be drawn and finished by that point. So it would have to look something like that. Okay? But now it also needs to be vertically stretched by 1.5. So I'd really need to draw it more like, let me bring up the blue pen again. I need to maybe go up to there and down to there. And this end, I'd have to end it right there. So best way to do this is take your beginning and starting points and divide it up into quarters. And now I know I have to hit that point right there, which is 1.5. And I have to hit this point right here, which is minus 1.5. So I need to draw it like this. Go up, come back through the midpoint, through the x-axis, come back, hit my minimum there, and come up. Only that should be curved. I'm not a very good artist. So I've vertically stretched it by 1.5, and I've horizontally compressed it by a factor of 2. Now,
those points between them, would those just be like increments of pi over 4?
yeah, they would be. In order to answer this question, though, specify the period and amplitude. We've done that. But then give the viewing window in which the graph is shown. What kind of calculator do you have?
I have it's a XPI 84, I think. Okay.
This one here?
Yeah.
Okay. Now let's see. Our function again is what? It's 1.5 times the sine of 2x, right?
Yep.
Okay. If I graph that, that's what I get. And notice that the vertical axis, each one of those hash marks is 1, because it's going up to 1.5 and down to minus 1.5. Horizontally is where we have to, in other words, if I want it to look like their picture exactly, what do I want to make my vertical axis be?
-2 to 2.
Good. What do I want my horizontal axis to be? Remember, that's pi right there.
So 2 pi.
So minus 2 pi to plus 2 pi. So if I go in here and I do It's been so long since I've used this calculator, I need window, don't I? Okay. So, my x minimum, what is minus 2 pi? That's, I could probably get by with minus 7. Now, first of all, I have to make sure I'm in radians. I am. So if I go from negative 7,
The pi button, you know.
oh, okay, I got you now. Yeah, let me clear that and go, the pi button is above that, so what do I need to do here? I need to do negative 2 pi, like that, right? To 2 pi. And I don't really care what the increments are. The y needs to go from negative 2 to plus 2. And that should do it. We should be looking at something very similar to what
Yeah, looks like it.
okay. Yeah, this is a pretty cool calculator. I found this online for free. Yeah, I know. These cost like $200 in the store. Okay, so for 14, what's our amplitude and our period? Let's write them down. Our amplitude goes from what to what?
Oh, that is negative 2 to 2.
Okay, so our amplitude is 2. What's our period?
2 pi over 3.
What should my window on the calculator be?
Looks like like negative 2 pi over 3 to 2 pi over 3.
What's the function again? It's 2 cosine 3x. 2 cosine 3x. And the window, again, is minus 2 pi divided by 3. To 2 pi divided by 3. And y goes from what?
Like negative 4 to 4.
Oops. There you have it. Do you have the TI-84 or the TI-83?
I have the 84.
Okay. I'm not sure there's any difference with these trig functions or anything else here. So, okay. What else? What next? 15? Do you have to do all of these or just odds or?
Sorry, what was that?
Let's see. I see a 14 and then a 19.
Oh, yeah. We can, you want another picture, or do you want to just like...
Well, can you verbalize 15? Is it something that can be verbalized? In other words, some of these can be verbalized, some can't.
Alright, here, I'll send you a picture. There's one that looks like it might be a little more tricky than the other.
Okay. Should be easier to send now. You should. What kind of camera? Are you using an Apple iPhone or
It's a Windows phone.
a Windows phone? Okay. A Windows phone? What? Really? Okay. You might be the first person I've come across that has that. Everybody seems to either have the iPhone or a Samsung. So you don't have the Android application.
No, I don't.
Use Windows. Yeah. Well, I can only guess as to how they work, but I'm presuming that once you typed in my email, the next time you go to type it in, after you type in 2 letters, it'll probably let you choose it from a list. Okay. Which makes it quite a bit easier to use. In fact, you might even have voice recognition in there. You might even be able to say, send this picture to David Count.
Yeah, I think I can do that.
Yeah, I think I can do something like that on my Samsung, I believe, also. I've never tried it, but...
Yeah, this has kind of like Windows equivalent of Siri.
Okay. Uh-huh. Is that the iPhone 6 or 6 Plus? Is that the newest one? Oh, you said Windows. Excuse me. Sorry.
Yeah.
Lost my train of thought for a moment.
Did you get the email?
Not yet, but let me...
I didn't. I wasn't sure if it sent it or not. I guess not.
Okay. No, actually, that mine. No, I'm recording.
Right. It was sent that time.
Okay. With a picture, it usually takes a little bit of time to get to me. Oddly enough, my phone gets it before my computer does. See, my phone just got it.
Oh.
Maybe at the same time. I think this only checks periodically.
And the one that I think we should do is 16.
Okay. That's the next one you have to do? Is 16?
Yeah.
Okay. Hold on a second. Let's see. That's the old one. I can close that one out. What's the period here?
That'll be 2 pi over x over 2.
No. B. What is B?
Oh, that'll just be 2 pi then?
What is B?
It's 1.
B is 1/2.
Oh.
In other words, when I say the sine of x over 2, that's the same as the sine of 1/2 x. So if b is 1/2, what's the period?
Pi over 4.
4 pi. In other
4 pi,
words,
right.
period is 2 pi over b. b is 1/2. When I divide by a fraction, I flip it and multiply. 4 pi. So from here to there is 4 pi.
Okay.
So on my window, what do I need my window to be? In other words, the amplitude is 5 and the period is 4 pi.
Looks like the y-axis needs to go from -10 to 10.
Okay, the vertical axis, right?
And the horizontal axis will be from -4 pi to 4 pi.
Correct. 17 next, I hope. Merely because it has a negative sign in it. Now,
Okay.
do you know how to handle a negative sign?
It's like mirrored over the x-axis.
Exactly. In other words, if I said, let's plot this, y equal minus sine of x, then it's just mirrored. It starts down and goes up, like that. Okay, so what's the amplitude of this?
4.
And the period?
2 pi over 3.
Which is? So it's 2 pi divided by pi over 3. What is that?
Yeah, I'm not really sure how to...
Flip when you divide by a fraction, flip it and multiply. So that's the same as 2 pi times 3 over pi. Pi's cancel. Period is 6. Okay, you with me?
Yeah.
What does my x-axis need to go to from what to what?
Sorry, I didn't catch the first bit of that.
The x-axis window, looking at this graph, if my period is 6,
So that'll be -3 to 3.
correct? And the vertical axis goes from what?
It looks like 5 to -5.
Yeah, -5 to 5, right. Okay. About 18. Do you have to do 18?
Yeah, let's do that one.
Okay. Amplitude clearly is 3. What's the period?
So that should be 2.
Correct. So my x window, if my period is 2, what's my x window have to go from?
It's like -4 to +4.
Good. And what's my y window need to go from?
-5 to 5.
Uh-huh. $19?
Sorry, what'd you say?
What's the next one we need to look at? 19?
Sure.
You seem to have a pretty good understanding of these.
I remember them vaguely from last year.
Ah, okay. Because we made a pretty big jump from the unit circle to the sinusoid function.
Yeah.
Now, there is one thing worth noticing, that let me just mention it. If you have tangent instead of sine or cosine, it still works. It's just that the period is pi for tangent, not 2 pi. So
Okay.
if you have a b, in other words, let's say if I wanted to know how to plot tangent of 2x. Well, b is 2, but the period would be pi divided by 2.
All right.
Okay, so the period for sine and cosine is 2 pi. The period for tangent is pi.
All right.
The natural periods.
Right. Let me see what I have next on here.
Let's do at least 19. Just make sure we understand what they're asking here.
Okay.
Even if you don't have to do it, it's worth doing. So this is going to go to 2 pi because there's no, in other words, b is 1. The amplitude is 2, so I'm going to go up to 2, down to minus 2. I'm going to quarter point that thing. Make sure that I go up to the maximum, down through there, down to my minimum, back up to there. And they want me to go from minus 2 pi to 2 pi, so I got to draw it out to minus 2 pi also. And let's see. Is that right? I think it's right.
Yep.
Identify the maximum and minimum values.
So would that just be like the amplitude?
Yes, they're referring to the y value. In other words, they're not, at least I believe, that they're not asking at what point this maximum is achieved. It's achieved at pi over 2. They're asking what is it? The maximum is 2. And there's actually 2 of them. I have a maximum there and a maximum there. The minimum, minus 2, it occurs there and there. The zeros of the function. Now when they ask about the zeros of the function, they're asking about where it occurs on the horizontal axis. Because we know where that occurs on the vertical axis. It occurs at y equals 0. So the zeros obviously occur there, 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 and there. What are those points? First one's minus 2 pi. What's this one here?
Pi.
And the next one?
0. Pi.
And those are your 5 zeros. Okay, let's see. We got about 15 minutes left. I don't know how many more you have to do or which ones you want to do.
Let's see. So these ones are a bit different here. So it says solve for x in a given interval. You should be able to find these numbers on a calculator using reference triangles in the proper quadrant.
Okay.
So we have sine x equals 1/2.
And we want everything, x is bounded from 0 to 2 pi maybe?
Yeah, it says 0 is less than or equal to x is less than or equal to pi over 2.
Only pi over 2. Okay. Oh, so that tells us it's in the first quadrant. And it's less than or equal to here?
Yeah.
Okay.
It's less than or equal to on both of them.
What is the only angle? In other words, x is an angle. You take the trig function of an angle to get a number. So if we were using a calculator, we could do what? We could say x is equal to the inverse sine of 1/2 by definition. If the sine of x is equal to 1/2, then x is equal to the inverse sine of 1/2. But they probably want you to do this without a calculator, correct?
Yeah.
So what angle is the sine equal to 1/2?
That'd be
There's your two unit triangles.
okay. So it'd be 30 then.
Uh-huh. So 30 degrees, only because they defined it as pi over 2 in radians, they probably want the answer in radians. What is that in radians?
That is pi over 6.
Yeah, notice that this times that's always 180. In other words, 45 degrees is equal to pi over 4. 4 times 45 is 180.
Oh, that's handy.
Yeah, it helps. Now, it's only true for if you don't have a numerator. In other words, it's not that helpful for 2 pi over 3. Then I would go back to the conversion factor, although not really. 2 pi over 3 has got to be 60, so 2 pi over 3 must be 120. So it actually helps even when you have another number in the numerator.
Okay.
What's another one? And that's the only angle in the first quadrant where the sine of that angle is equal to 1/2.
All right. The next one is sine of x equals 1/2, and then the boundaries are pi over 2 is less than x, or pi over 2 is less than or equal to x, is less than or equal to pi.
Which quadrant are we in?
That would be in the second quadrant.
Okay. What is the second quadrant angle that's the equivalent of 30 degrees?
150.
Yes. That's the answer. X
All right.
equals 150. Now, what is that in radians?
5 pi over 6.
Yeah. That's a pretty fast translation. You did good. Did you do that because it was 30 degrees short of pi, and 30 is pi over 6, so that's pi over 6 short of pi?
Yeah.
Okay. Good. What else you got?
This one looks tricky.
Okay.
Cosine x equals negative square root of 2 over 2. Boundaries are pi over 2 is less than or equal to x is less than or equal to pi.
Which quadrant?
Now, the third one again?
Second.
All right, second.
Which is a good thing because cosine should be negative in the second, right?
Yeah.
Which angle is it from my little triangles down there? Now this is a little bit tricky because you can't get it directly from my triangles, but let me go ahead. They may have actually taught you this second triangle with different dimensions. They may have labeled it like that. Yes, no?
I'm pretty sure that's both of those.
They're both the same. In other words, they're both similar triangles. They're both 45, 45, 90. It's just that this triangle is root 2 times this triangle. And the only reason they do that is because it keeps you from having to rationalize it, at least the sine and cosine. In other words, had I given you that as the basic triangle, now which angle is the cosine equal to square root of 2 over 2?
45.
Right. I didn't really need this triangle to see that, because I can see that the cosine of 45 is 1 over root 2, which rationalizes to root 2 over 2.
Oh.
Okay? So be aware of that when you see this, that it may show up a little different on the unit triangles, and you have a choice as to how to label these. I could label these anything I wanted. I could have labeled it 10, 10, and 10 root 2. Okay? I prefer 1 myself to root 2, root 2, 2. And for one thing, doing root 2, 2 only works if you're doing sine and cosine. If you're doing secant and cosecant, you end up having to rationalize that, because now you have the irrational number in the denominator for those. So for sine and cosine, I can kind of see where root 2, 2 works a little bit better, but it also confuses the issue if you teach it both ways. So I kind of like this way because I can, we're used to calling stuff the unit circle. The unit circle means the radius is always 1. Well, if these are my unit special triangles, the side opposite the smallest angle is always 1. And it makes it kind of easier to memorize, I think.
Yeah.
As long as you can do this translation, that 1 over root 2 is the same as root 2 over 2. And incidentally, that's the case with everything. 1 over root 3 is root 3 over 3. 1 over root 5 is root 5 over 5. So whenever you're rationalizing something that has an irrational denominator, you can know that. So our angle is 45 degrees, but we're in the second quadrant. So what second quadrant angle is the equivalent of 45 degrees?
3 pi over 4?
Yes. It's good that you don't have to do it in degrees and translate. The sooner you can think in radians, the better off you'll be. Of course, it's kind of hard to do anyway. I mean, studying trig is like studying Greek, and then studying radians is like a different language, a different dialect of Greek.
Yeah.
So, but you can get to a point where you can kind of think in radians, and you don't always have to go back and forth between degrees and radians and do the translations. I could label this angle, instead of 45, I could label it pi over 4. And that's pi over 4, and this is pi over 6, and this is pi over 3. Okay? Got time for one more if you want to do one more?
No, I think that'll be good.
Okay. And let's see, we have a half hour scheduled for Friday at 7:30?
Yep.
Tell you what, you're a special student. I don't get too many people that want sessions on Friday night.
Yeah, I figured it was probably good to have more than one session in a week, and that seemed like a good time. So.
Yeah, no, that works great for me. So I'll be happy to do it. I will talk.
Could you like lock up this time right here for me?
Yes. You want this 7:30 for an hour on Mondays?
Tuesday.
Or Tuesdays, excuse me.
Yeah.
Okay. Is that the only one you want me to lock up? You don't want me to lock up the Friday one? You don't need to lock it up. That'll always be open.
Yeah, we'll just leave that one open.
Okay. I will definitely do that.
All right.
I'll talk to you Friday. All right, Daniel.
All right.
Bye-bye.
Thanks.